So here's the solar system, there's the sun, there's the Earth, here's Jupiter, and here is Jupiter's innermost moon Io. Now it was known that Io takes precisely 42.5 hours to orbit around Jupiter. So if, from the Earth, you see Io emerge from behind Jupiter at, say, midnight on a Tuesday, then you know that it should re-emerge again at 6:30 on Thursday afternoon. Now one of the men charged with making precise tables of exactly when Io should be seen to emerge from behind Jupiter was the Danish astronomer Ole Rømer. But he noticed something surprising. Depending on the time of year, Io emerged later than expected, or earlier than expected. Now Rømer's genius was to realise that had nothing to do at all with the orbit of Io around Jupiter. It was to do with the orbit of the Earth around the Sun. See, what Rømer noticed was that when the Earth was in a position in its orbit so that it was close to Jupiter, then Io emerged earlier than it was expected to. Then, as a year passed and Earth moved around the Sun and got further away from Jupiter, Rømer noticed that Io then emerged later than it was expected to. Rømer realised that it takes time for light to travel from Jupiter to the Earth. So when the Earth is far away from Jupiter, it takes longer for the light to travel, and therefore you see Io emerge from behind Jupiter later than you would expect. Then, when the distance is small, it takes less time for the light to travel. Rømer had discovered that light doesn't travel instantaneously. It moves through space with a finite speed.